Hi, welcome to the infrared spectroscopy tutorial. My name is Gustavo Salazar, and today I'm going to show you how to obtain an infrared spectrum. This tutorial first briefly describes the principles which this technique is based on. Then we will learn how to prepare a sample, run the experiment, and analyze the resultant spectrum. In organic chemistry, the infrared spectroscopy technique, or IR technique, is a simple and quick way to identify functional groups. Consequently, these results are very useful in determining molecular structure. However, how do these experiments actually work? Well, all spectroscopy techniques depend on the interaction of atoms or molecules with electromagnetic radiation. In this particular case, the radiation is in the infrared region. When the infrared light hits a sample, the molecules absorb energy to produce different stretches and vibrations of their atoms or group of atoms. As we know, functional groups have a specific atomic arrangement. So the IR energy absorbed by a particular functional group will produce a very characteristic signal in the spectrum. For instance, the energy needed to stretch a carbonyl bond will be lower than the one required in stretching a carbon-hydrogen bond. In addition, there is a particular area in the infrared portion of the spectrum called fingerprint region. This region can be used to identify compounds exactly. This technique is so valuable that forensic scientists employ it regularly in their laboratories, especially because of the small quantities of sample that they need. Now, let's look at how the experiment is run. This, of course, depends on the particular instrumentation available. For instance, the instrument we have here today needs the preparation of a potassium bromide pellet when analyzing solid samples. This pellet is used as a support in order to have a somewhat transparent and homogeneous sample. Notice, the potassium bromide also absorbs energy in the infrared region. Therefore, we need to perform a background spectrum in order to eliminate this interference. This process is routinely set up for all the experiments done with this instrument. Before making the pellets, we need to make sure that our tools and potassium bromide are well dry, since even the smallest quantity of moisture could be detected by our instrument and interfere in our experiments. We can achieve this goal by keeping the materials in an oven at about 200 degrees Celsius for a couple of hours. To prepare the potassium bromide pellet, we need finely ground potassium bromide, about 200 milligrams. We then add the potassium bromide to our sample holder. After we're done adding, we close the holder and make our pellet using a manual press. Now, we only need to remove the two metal slices, and our pellet is ready. This pellet is going to help us to run the background scan, since it is only made of potassium bromide. The preparation of our sample follows the same procedure. However, we will use 197 milligrams of potassium bromide and 3 milligrams of the sample. Now, the preparation of a liquid sample follows the same principle. However, we're going to use the potassium bromide windows. To run the background, we take these two windows and put them in a holder. We seal the holder and we run our background. To run the liquid sample, we remove the top window we add a few drops of our sample. We put up the top window back again. We seal and we can run our sample. The IR spectrometer contains several key parts, all confined in one instrument. A beam of infrared radiation will be generated in the inside of the instrumentation. This light will come out through a small slit and hit one of our samples. We can have our liquid background or sample, or we could have our solid background or sample. The part of the light that is transmitted through the sample goes through a series of monochromators and gratings before being received by the detector. Finally, the signals are amplified and processed with the help of specific software. After we finish collecting our data, we get two different spectrum. The blue one is our background, and the black our sample. As you can see, the potassium bromide absorbs a lot of energy in the infrared spectrum. That's why we need to subtract its absorbance. Now that we have our spectrum, we can select it, label its peaks, and start analysis. As we can see, we have some aromatic peaks and a carbonyl peak here.